right. Hello, everyone. So today I want to talk about how dependency injection saved my untestable app. First, a little bit about me. I'm Laurent. I'm a developer experience engineer at Melisearch. You can find me on social media, usually at Strift or Strift Codes on Twitter or laurentcazanove.com on Blue Sky. LaurentCazanove.com also happens to be my blog, so you can find my writing there. All right, today I want to talk about how to build testable apps with dependency injection. So here's a little bit of story beforehand. This happened to me because I had a legacy app running over Firebase, and I wanted to try and migrate to Supabase. I had good integrations test using Firebase and militaries in local, but my business logic was just like too tightly coupled with the Firebase code. So basically what started as a keep it simple approach ended up having like leaking implementation details, super bloated, composable, and untestable code in general because of the mess of business and dependency logic. It was really hard to know where to start for this migration, and what felt particularly bad was that there was no way for me to leverage my test to help in that migration. Fortunately, I found a solution, and that's what I want to talk about today. I want to talk about how we can build testable apps using dependency injection. So I hope you walk away with the following learnings, which is how we can clean up our composables, how we can decouple the business logic from the dependencies, and how we can write more testable code. All right, so we'll do this using a simple example of a user list component. So our component uses a get users function that it receives from the use users composable, and it uses it in a async data hook to do the data fetching. And then we simply display the data. That's it. So if we look at the use user composable code, it uses the Supabase client. So yeah, here I have the opposite example. I'm using Supabase from the get-go, but it's the same. And then the get user function is just actually using Supabase to retrieve the users from the database, and then we return that function so that components can use it from the composable. Fairly simple composable as well. How can we test this is the question. Testing our component with Nuxt, here's the anatomy of a test. So first we have the imports, obviously. Then we have the test case. So this is the user list component, and we have a single test. We test that it renders a user list. Then we mount the suspended component. A mount suspended is a helper from Nuxt.js that allows us to resolve the top level awaits in our components so that we can actually test the data fetching logic. And then we have the assertion. I want to check that there are 3 users, Harry, Ron, and Hermione, on my page. So this is good, but what if I don't want to use Supabase in my test? Say I want to use an in-memory database to speed up testing in local. So I guess the naive approach would be simply mocking the use users composable so that it returns the list of users. That would speed up the test, right? Sounds pretty good, doesn't it? Yeah, probably not. First of all, we have like a tiny problem, which is with this way of doing it, we pretty much need to write a new mock implementation for every test we have. But the bigger problem we have is that we are actually testing the implementation detail of our component. And we should only test inputs and outputs, not implementation details of components. Here's what the Vue.js documentation recommends about component testing. Testing the inputs include testing the props, the interactions, like user clicking, for example, and the data stream, like anything that would come in and would affect your component in a similar way as prop would do, basically. And the outputs, output is DOM elements, so what's rendered, the emitted events, like if someone clicks, I don't know, on a button to close a model, you want to check that this event is emitted, and the side effects like logging to the console, for example. The rest is implementation details. So in the case of our use users composable, it is an internal implementation detail of our component. We don't want the test to break if that implementation detail change. Say, instead of calling the function get users, I want to call it fetch users. I don't want my test to break for this. So if you want to look at it from another angle, consider that we want to make the test readability better. Our concern here is actually the database dependency, not the behavior of the component. We just want to use an in-memory database instead of Supabase to speed up the tests. So I think the code should convey this. We should make it clear to the reader that the business logic is not the concern here. It's simply the dependency. So knowing that, how can we write a better test? So another attempt would be to mock the database, right? So instead of mocking the use user function, we would mock the use Supabase client function. And we will make it return the data we want, Harry, Ron, and Hermione, right? So this is simple enough for a basic use case, but you can see that it can easily get very complicated if we had multiple database calls, right? What if we wanted different columns in our user table, or if we wanted to query a different table? We can see that this is not scalable because our mock would pretty much require advanced factory implementation to be able to handle all the use cases, or we would pretty much have to rewrite the mock implementation for each test. But it works. Still, is this really what we want to do? Because now our test is actually very tightly coupled with our Supabase implementation, which feels really out of place. The goal here is not to check that we implemented Supabase properly. It's actually all the opposite. We just wanted to remove Supabase from the picture altogether. This is very complex to test because I think our code is actually very integrated with the Supabase dependency. And this should also raise warning about another anti-pattern of testing, which is we should not mock what we don't own. And here we don't own Supabase dependency. So there's probably another way to do it better. No, they say that we can solve any problem in software engineering by introducing an extra level of interaction. If we talk about this with more simple terms, it basically means that we can solve any problem of complexity like the one we have by introducing a new level of abstraction. Okay, concretely, this means we should wrap our dependency. We should wrap the stuff we don't own so that we can create a API that we have control over. And let's see how we can do this. So in our case, we can create a use database composable that will wrap the use Supabase client. So this code does two things. We pull the Supabase client, and then we implement a method, which is called findAll, and that wraps the Supabase implementation detail. And by doing so, we abstracted away the implementation detail of interacting with database. Now, our use users function, or composable rather, is much simpler. We just have to pull the database and we use it to find all users. The benefits is that now the code is focused on business logic. So this makes reading it much easier, but it will also make migration easier and make testing easier. Let's see what this changes our test. So yeah, now we can just mark the use database composable, which is our wrapper of the dependency, instead of marking the Superbase client, which is conceptually better, right? It's more explicit for code readers. We're marking the interface with the dependency, not the way the dependency itself works. And we're not marking use user either, which is the internal behavior of our component. At least now, if I don't want to use Superbase, I can only mark this composable, right? Yay! But we still can't swap databases. There's no easy way for us to use another real database for test, say an in-memory database, like I said, to speed up the testing. And we can only mark, not actually replace the dependency. So our use database composable is still tightly coupled with Superbase. We just move the relationship between the application code and the dependency one level higher. And what if we want to change databases? Like in my scenario, say I want to migrate from Superbase to Firebase, which was the opposite of what happened to me in real life. Or I want to migrate, like I said, to an in-memory database to speed up the test. Can we leverage our test for this? Imagine I want to do some TDD and just like replace Superbase with Firebase in my code and write some optimistic code and then try and use the test to fix the implementation. What would happen? Nightmare. We'd change the code, but all the tests will still work because all connections to the database are mocked. This might be what we want if you had dedicated integration tests for the Superbase implementation, but it's not our scenario here. But what feels worse is that there is no way to run the test and like simply say, use Firebase instead of Superbase. And despite having written all these tests, there's no way to leverage them to help in our migration. So this just felt wrong, right? Let's zoom in a bit, zoom out rather, and look at it from like a software design point of view. What we're dealing with here is a case of tight coupling between our composable, the use database composable, and its dependency, which is Superbase in that case. It might not look like it because Nuxt module actually creates the instance for us, and we just call the use Superbase client composable to retrieve it. But in reality, there's a strong relationship between these two parts of the code. Use database is actually responsible for choosing the dependency to use. Let's look at what would be the alternative to clarify what I'm saying. So what are the alternatives? So first we have the scenario which we are currently in, which is the function is responsible for its dependency. Let's look at the example of this function. The getUserById function here is actually responsible for creating the database. And then it uses the database to retrieve a user. The opposite would be the function dependency being injected. So in this example, we can see that getUserById receive the database by function parameters, and then it can simply use it instead of having to know how to build it. So the second scenario is actually a well-known design pattern called dependency injection. Dependency injection, often shortened DI, is a design pattern where objects or modules, part of the codes, do not create their own dependencies. Instead, the dependencies are injected from the outside, like we saw with function parameters, or it can be the case with like a constructor for a class. Basically, let's see how we can apply this to our use database example. We have this composable, right, that allows us to interact with the database, but we don't want it to be responsible for actually creating the connection with the database, right? We want it to receive this dependency by injection, so it would not have to care about which database it's using or how is the database created. It would basically simply rely on an interface, a contract of, okay, this is how the database works. This is the available methods I can work with. And the function would just have to say, okay, I use the database, I query a table, and I return the data. That's it. How can we implement this? With Nuxt. So with Nuxt, today I want to show you how to do it using plugins. So we could use a Nuxt plugin to provide the dependency, and then the other part of the code we'll be able to use inject, or in the case of Nuxt, pull it from the Nuxt app to retrieve the dependency and use it anywhere. By doing so, we would actually be using the Nuxt app as our IOC container. In the context of dependency injection, IOC stands for inversion of control. The inversion of control containers centralizes the responsibility of creating and managing the dependencies, if you have many. And this centralization is actually what makes it easier to swap the implementations. For example, for test, to use the in-memory database, or in the case of a migration, to move over Firebase. By the way, this works very similarly if you're using vanilla Vue. You would just be using app-level provide instead of Nuxt provide. All right, let's see how we can do this with the Nuxt plugin. So we define our plugin. In our plugin, we instantiate our Supabase service, and we provide it to the app. We can see here that we are importing a type database. This is the interface that the app works with. It doesn't care that it's actually Supabase. It just knows it's a database. And now our use database function becomes a simple wrapper around the injected service. And we are able to move the code responsible for implementing Supabase to a dedicated file, right? So this interface will implement, this class rather, will implement our database interface, and will implement the find all method that is actually using Supabase, but now that's contained in here. We have a dedicated class for this implementation, and it's not leaking in the use database function. And this opens up new possibilities, right? Because now we can have multiple implementation of the database interface, and we could say, check for runtime configuration to instantiate different class and have different dependencies per different environment. So if you want to update our plugin to do that, instead of simply instantiating the Supabase plugin, we could first check for the runtime configuration, instantiate a different database implementation based on that config. All right, let's zoom out again and see what we really gained by doing so. The first benefit, obviously, is the separation of concerns. What do I mean by that? Now our code pulls its dependencies from the IOC container. So our business logic is completely free of dependency concern. This means our use database composable is not responsible anymore for retrieving the database or knowing how to instantiate it or configure it. It is injected from the outside. Let's see what this unlocks in our test. We can now swap dependency at the test level. This example uses Vue, so I have to wrap my component in a suspense so that we can resolve top-level await. But we can see here that when we mount the component, we can inject a database at the Vue instance level. And we're not mocking any internal behavior here, and we're providing a real database, not a mock. So in the case of a Firebase migration example, this would help us verify that our implementation of the Firebase database work. We can still use mock, by the way, if we need it for specific example, but now we have more possibilities. Let's see the same thing with Nuxt. We can also swap the dependency at the test level when using Nuxt. But because we're using Nuxt, we're actually still relying on the mock here because, as we saw earlier, our implementation relies on Nuxt application providing the dependency. So it needs to run in the Nuxt app and it needs to have the Nuxt app available. So I am mocking the use database function so that it returns a different implementation of the database. But we're not mocking the database here. We're just mocking the wrapper around inject. We're passing it a real implementation, so it can still help us in our migration scenario. And we're still not mocking any internals of our component's behavior. So this is how we can do it at the test level. But thanks to our new implementation, we can even do it at a higher level. We can actually swap the dependency per environment using the runtime configuration option we introduced earlier. So here, I'm just updating the runtime configuration via vtest. So when I run my test, I want the database driver to be memory. And then my plugin will use that value to instantiate a different driver, and all my tests will run with a different dependency. So in our example, I could have the memory driver to run tests with in-memory database in local. I could run the test with the Firebase implementation, say in a staging environment, and I could still have my app running with a Superbase database implementation in production. All right, let's recap what we learned here. So I think the main benefits of dependency injection in our Vue or Nuxt app here is that we managed to decouple the business logic, so fetching users from the dependency, which is connecting to Superbase user table and making a select request. We also managed to centralize the dependency creation and configuration in the Nuxt plugin. And this actually enabled us to write more robust and explicit tests because now there's a single place to manage dependency, a single place to override it. And this in turn resulted in facilitating the implementation changes. Basically, to summarize, dependency injection allows for a more flexible architecture, and this enables easier evolutions and more leverage for your tests. Before I let you continue enjoy this conference, some closing thoughts. A couple of things to keep in mind, basically. Both in Nuxt and in Vue, the plugin codes we have run on every page. So if you are going to implement dependency injection the same way I did, you need to make sure you lazy load your imports to avoid bundling too much dependencies in your bundle entry point. Furthermore, you need to make sure you're not providing unnecessary services dependencies in your bundle because, it will run on every page, like I said. And I think that is it. Thank you for your attention. If you have any question regarding the talk, feel free to find me online or on social medias. And until then, enjoy the conference.